Welcome to another episode of Environmental Digest. Today, we're going to talk about something that's happening right under our feet, a biological revolution that could completely change how we grow our food. We're diving into the emerging biological solutions that are poised to replace traditional fertilizers. Okay, so let's set the stage here. At the very heart of modern agriculture, there's this massive dilemma. On the one hand, nitrogen fertilizer is, well, it's nothing short of a miracle. It's estimated to help grow enough food for half the world's population. But here's the catch. Producing it eats up a staggering 2% of all global energy. So what we have is a classic case of a solution that's become a huge problem itself.
So you might be asking, how did we get into this mess? Well, the story starts more than 100 years ago with an industrial process that honestly changed the world. The Haber-Bosch process. It was this incredible breakthrough that let us literally pull nitrogen out of thin air and turn it into ammonia for fertilizer. But it comes with a massive, and for a long time, kind of hidden environmental cost.
To make this whole process work, you basically need to use brute force. First up, you need incredible heat. We're talking about 500 degrees Celsius. That alone takes a ridiculous amount of energy, which, you guessed it, has pretty much always come from burning fossil fuels like natural gas.
But heat isn't even enough. On top of that, you need absolutely crushing pressure. We're talking over 100 times the normal pressure of our atmosphere. It's this 1-2 punch of extreme heat and pressure that forces the nitrogen in the air to react with hydrogen. It works, for sure, but man is it energy intensive.
So what's the bottom line? Let's talk direct climate impact just from making the stuff. The process of synthesizing ammonia for fertilizer is responsible for about 1.5% of all global carbon dioxide emissions. That is a gigantic footprint for just a single industrial process. And, the environmental damage doesn't just stop at the factory gates. When all that synthetic fertilizer gets spread on fields, a lot of it isn't even used by the plants. This leftover nitrogen gets converted by microbes in the soil into something called nitrous oxide, or N2O. And that's a really powerful greenhouse gas that just leaks right into the atmosphere. And here's the part that really should make you sit up and listen. Nitrous oxide isn't just another greenhouse gas. Molecule for molecule, it's about 300 times more potent at trapping heat than carbon dioxide. So every little bit that escapes from a farm field is doing an incredible amount of damage. Okay, so after hearing about that whole brute force industrial method, you have to wonder, isn't there a better way? Well, of course there is. It turns out nature figured out a much more elegant solution eons ago. I mean, for literally billions of years, life on Earth has been quietly solving this exact problem. There's this natural, symbiotic relationship between plants and microbes that pulls nitrogen from the air and fixes it into nutrients. And it does it all at normal, everyday temperatures and pressures. It's just elegant, silent, and unbelievably efficient. And this is where our story gets really exciting. Scientists and innovators are now figuring out how to harness nature's genius. And a key player in this new biological revolution is a particular microbe with a bit of a mouthful for a name, Xanthobacter autotrophicus.
And this isn't just some fantasy happening in a lab. As Harrison Yoon, the CTO of Kula Bio, puts it, the whole point is to create solutions that are actually practical for farmers. The key is making this new tech just as easy and reliable as the old synthetic stuff. Just, without all the environmental baggage.
So how in the world does this work? Well, what makes Xanthobacter autotrophicus so special is that it can store its own energy. There's a proprietary process that essentially supercharges these microbes, giving them their own internal battery pack. So when they're applied to the soil, they don't have to wait around for the plant to feed them. Nope, they get to work right away, converting nitrogen exactly where the plant roots need it most.
And the results? They're really impressive. Because these little guys show up with their own packed lunch, so to speak, they are way more effective. Studies have actually shown they have up to 65% greater efficiency at fixing nitrogen compared to other, more conventional bacteria. That is a huge leap forward.
But the benefits here go way beyond just feeding a plant some nitrogen. This is really about revitalizing the entire soil ecosystem, and that has some pretty profound effects for our climate. So let's connect the dots back to that super potent greenhouse gas we talked about earlier, N2O. Because these microbes deliver nitrogen so efficiently right to the plant's roots, there's way less excess just sitting around in the soil. And less excess nitrogen means less raw material that can be turned into nitrous oxide. You're cutting those harmful emissions right at the source. And there's another incredible benefit: building healthier soil that can actually store more carbon. See, when these good microbes are thriving, the whole soil food web gets healthier. Then, when they die, their remains, which scientists call necromass, become this critical building block for stable organic matter in the soil. And that helps lock carbon away for the long term, basically turning our farmland into a carbon sink.
So what does this all add up to? Well, I think we're really witnessing the dawn of a new age in agriculture. It's one that finally sees the immense power of biology as a core technology for farming sustainably.
And hey, this isn't just some niche idea. The World Economic Forum has actually named green nitrogen fixation as one of its top 10 emerging technologies for 2025. That really highlights just how critical this shift is for hitting our global goals on food security and climate action.
And that really leaves us with a fascinating final thought to chew on. For more than a century, we've relied on industrial might, on heat and pressure and giant factories to feed the world. But as we look to the future, it really seems like our greatest allies might not be giant factories after all, but the trillions of invisible, powerful microbes working silently right under our feet.